Hi there, welcome to Isabel Explains. In this video, we will talk about how to understand the formula for compound interest. Let's go. So you probably have seen the formula for compound interest, which is A equals B, parenthesis 1 plus R over N, all of that elevated to the NT. But what the heck does that even mean? Where did that formula come from? First, let's start with when do we use this formula? Well, we normally use it in two kinds of scenarios. A, when we are calculating the interest we have to pay when we take out debt. Or B, when we're calculating the interest that we're going to earn on our money inside of some sort of savings or investment account. For the sake of this video and to keep things positive, we will be using the second scenario of saving money. So what are all these letters on the compound interest formula? Well, let's start with the A. A is the final amount. P is the principal, which is the amount that you started with or the amount that you put into that savings account. R is the interest rate, which is written as a decimal. N is the number of times that the interest compounds in 1 year. And T is the time in years. Unlike simple interest, where you earn the same amount of interest every single year, with compound interest, the amount of interest that you earn increases every year because compound interest is really more like accumulated interest, which means that every time you earn interest, that total amount becomes your principal for the following year. For example, let's suppose that you save $1,000 on a certificate of deposit. And if you don't know what that is, you gotta check out my video on CDs after this video. All right, let's suppose that the interest rate of this account is 3% APY, which means annual percent yield. And annual just means per year. And it compounds yearly. After 1 year, you will have accumulated 3% interest, which is $30. But if that interest was compounded or accumulated daily throughout the entire year, then you would have accumulated $30.45, which doesn't sound like a lot, but the next year, your principal is technically no longer $1,000, but $1,030.45. And 3% of $1,030.45 compounded daily for another year is $31.38, which means that you end year 2 with $1,061.83. Now, this will keep growing a little by little every single year, and by year 5, you will have accumulated $161.83. And after 50 years, you would have accumulated over $3,000 in interest for doing absolutely nothing. That is the beauty of compound interest. Now, let's break down the formula. We said that A is the final amount. In this case, it's the $4,481.41 that you will have in your savings account after 50 years. The P is the $1,000 that you started with. The R is the interest rate in decimal, so in this case 0.03. The N is the number of times interest is compounded per year, in this case 365, because it is compounded daily. And T is 50 years. If we plug in those numbers, we get that A equals 1,000 parentheses 1 plus 0.03 divided by 365, all of that elevated to 365 times 50. The reason why we have the 1 here is because we are finding the total amount, including the initial amount, not just the interest. The 1 is just going to keep adding that previous full amount plus the interest. Now, if you see here, the interest is divided by the N, which is the number of times the interest is compounded per year. Now, I want to make a quick side note here and let you know what the most common values of N are. Since N is the number of times the interest is compounded per year, when the interest is compounded yearly, N equals 1. When interest is compounded every 6 months, N equals 2. When it is compounded quarterly or every 3 months, N equals 4. When it is compounded monthly, N equals 12. When it is compounded bi-weekly, N equals 26. When it is compounded weekly, N equals 52. And when it is compounded daily, like in our example, N equals 365. Now back to the example. The reason why we divide by N is because the interest, as I mentioned before, is APY, which is annual percent yield, meaning you're going to be making 3% divided by 365, which is 0.00822% per day. Again, this doesn't sound like a lot, but when you're going to elevate all of that to 365 times 50, right, which is over 18,000 times, which is how many times you'll accumulate interest in 50 years when it is compounded daily. That's why at the end of 50 years, you'll have a total of almost $4,500 because the interest has been accumulating so often. if the interest would have only been accumulated once a year, aka compounded yearly, you would have only had $4,383.91, which is still a lot, but it's about $100 less than if it was compounded daily. So in reality, it is not as important how often it is compounded as much as it is how long it is compounded for. Your turn. If you were to invest $5,000 at 10% interest rate compounded yearly, how much money will you have after 50 years? Now pause this video and work it out. Then let's come back and see if you got it right. All right, so when we set up the equation, is A equals 5,000 parentheses 1 plus 0.1 divided by 1 elevated to the 1 times 50, which gives you $586,954.26. Yep, that's over $500,000. And that is without adding any more money to that account. Imagine if you invested like $5,000 every year for just 10 years. After 10 years, you would have made over $92,000. If you don't even invest any money after that and just let it grow at 10% rate, in another 40 years, you'll have over $4 million. And I know that $5,000 may sound like a lot of money for you right now, but actually, if you do the math, that's less than $100 a week. That's why you need to start investing now that you're young. And you may say, well, Miss Isabel, but I'm a minor. I cannot invest yet. I have to wait until I'm 18. Wrong. Do you want to know how you can start investing before you turn 18? I'll show you in the next video. See you there.